Yeah, so this semester we worked with BASF. I had a great time this semester, and this team was wonderful, and they put together some really great things, so I'll let them introduce themselves.
I am Phil Wall. I'm a computer science major.
I'm Nicholas, computer science major and math minor.
My name's David Vennon. I'm seeking dual degrees in computer science and physics with a minor in robotics.
My name is Peter Wynn. I'm a full-time CS student, and I'm a senior.
My name is Ryan Lamb, computer science student.
And I'm Valerio. I study environmental policy here. So first question is, who is BASF? Well, they're the biggest chemical company in the world. They operate in 90 different countries and serve 190 countries. They have over 110,000 employees, so that's a lot of knowledge to manage. They operate in these 6 sectors, but all you need to know is if you need a chemical, they probably make it. Right down the river, they operate in Geismar. This is their largest plant in North America. They have over 2,000 employees and 32 production plants. You cannot walk across this plant. You have to drive across it. So that's a lot of material and a lot of maintenance to do, and all that maintenance requires a lot of planning. So our problem was with planning and job planning, and that's where we tried to assist. So Ryan will tell us a little bit more about what the issue is between this.
Thank you, Valerio. So here we have Vanessa. Vanessa is one of our maintenance planners at BASF, and she has been tasked with creating a job plan. In order to create these job plans, she needs to use older files that she has been looking for to create a new job plan. But the thing is, what our problem is that planning maintenance jobs is very time consuming. We have to rely on old network drives that have been possibly made by people who have retired years ago, manual file copying, and maybe some planners might not be as tech savvy as others. But as you can see, Vanessa is very frustrated. She has to dive deep in through complex file structures and possibly incorrect file names. Here we have is a SAP file. SAP file is essentially a set of steps that's what BASF uses to plan their things. But as you can see, the deeper we get into these files, the more complicated it gets. Our project, essentially, our streamline for the project, essentially will make it easier for a job planner and make it overall easier for her to create it. I will hand it off to Peter to discuss the cost.
Thank you. So what is the cost of planning at BASF? Well, at BASF, there's roughly 8,700 pressure safety valves, or PSVs, with 3 full-time planners just for them. Each of these planners are making $75 an hour. But at the Geismar site, there are 30 full-time planners. And when that workload starts to ramp up, they need to hire about 27 contracted planners on top of that. These contracted planners come with administrative costs, and they don't know how BASF functions. So they need to be trained on the job, costing the company even more money. And with that increased workload comes overtime. So every single planner is now looking at making upwards of $112 an hour. So what does that cost the company just at the Geismar site on an annual basis? It costs them over $7.5 million. And I'm going to pass it over to David to speak about how we built upon past foundations.
Thank you, Peter. So you've heard a little bit about the problem. Let's talk a little bit about the solutions. First and foremost, we need to make it so that these job planners can access the data quickly. Now, this is the 4th year BASF has partnered with LSU. And the previous iterations of this project, they've gone through and they've taken all of BASF's files, they've digitized them, they've stripped the text out of them, they've thrown them into a special database so we can search based on content rather than specific keywords and spelling, especially when it comes to these alphanumeric codes. That gets tricky. So if you take a look at the left-hand side, this file structure, some of these folders are 7, 8, 9 layers deep, and this isn't even the worst example. It gives me anxiety thinking about trying to go through this. I mean, we're at the end of the semester, I'm trying to study for finals, and I can't find my own files, and I know where I put them. I can't imagine going back through something that's been hidden away years ago, possibly even more than a decade, by somebody else. It's finding a needle in a haystack. So what we need to do, we need to build the magnet to get those needles out. So first and foremost, they've gone through and they've embedded all of this so that we can search by content. We've developed a tool that rapidly pulls the pertinent files forward and also takes the pertinent data from those files and consolidates them into a nice, easy outline for these job plans. Now, to talk a little bit about the technology, I'd like to call Nick forward.
Thank you. So for our programming language, we chose Python. So Python, it's our programming language that we chose, but it's also the language of AI. So if you're going to be making anything in the field of AI, you're probably going to be coding in Python. We're also using Apache Tika. So earlier you saw images in the previous slides of all the different job plans, and they can be really complicated. They can also be many different formats. They can be PDF files, they can be Word documents, they can be Excel sheets, they can be anything really. And because of that, we want to represent them all in the same format so that we can deal with them later on. Apache Tika allows us to do that. It converts everything into text, which will be useful later on. For our database, we're using a database called ParadeDB. ParadeDB is a very special type of database called a vector database that plays really well into AI applications. For our language model, we're using Qwen. So you've probably all heard of ChatGPT before, which is OpenAI's language model. So instead of GPT, we decided to go with Qwen, and this allows us to run everything on our own hardware and potentially save compute costs. For our user interface, we're using Streamlit. So Streamlit is a software that allows us to very cleanly display a very nice looking user interface to the user. And the reason that we decided to go with this is because BASF has used this internally in the past for previous internal projects, and they found success with it. So how do all of these technologies actually work with each other? How do they actually interact with each other? So it starts off with our initial files, and these can be Word documents, these can be Excel sheets, these can be PDF files, or even images. And we pass them through Apache Tika, and out comes the extracted text. This text is then added into our database. But in addition to that, we also supply the text to our language model so that we can extract further insights, such as summaries and metadata, which would be added to our database in addition to the original text. So our users interact with our Streamlit interface, but how does the Streamlit interface actually interact with the rest of our system? So it starts off on the bottom with a user query. The user query gets sent to our database, and our database will find all the most relevant files that pertain to that query. Those relevant files, those relevant job plans, will then be sent into our language model, and our language model will generate a new job plan based on the existing ones. So for our demo, I'm going to pass it on to Taylor to explain this.
Hey everyone. So for our demo, we decided to give kind of a walkthrough of how Vanessa will actually interact with our application. So this is the home page of our application. So it's split into two sections. At the bottom here, we have like a small section of our database. So it has all the found files from all the information that we downloaded. You can see the 4,491 matches. This is a subsection of the entire 7 terabyte maintenance folder that we got. So it's just a small section that we did the demo on. At the top here, you can see two search features, functional location and work order. For functional location, think of this as the equipment number. So the actual piece of equipment, for example, let's say acetylene. The acetylene is a unit, so this PSV, if just to find it, you would search for that sequence for the functional location. The work order, think of that as a past job plan. So it has a unique number. So if they're given this, they can search for a past job plan and give it. More than likely, a job planner will be given a functional location, as that's more easier to find. For this example, we were given functional location. Vanessa will click the search feature, and it finds 3 matches. Vanessa will then go through and find all the ones that she wants to include in, and then hit Create Job Plan from a selection. This will open up a new page with 2 main tabs. The first tab is a SAP Matches tab. So SAP is an enterprise resource planner that BASF uses globally. So this has additional information that Vanessa might need to complete the job plan. The next section is the job plan tab. This has 4 main tabs. It first brings you to a summary tab that has 4 main things, which source work orders, input steps, consensus steps, and unique steps. This is a brief overview of the job plan that it made. The common steps is the next tab and one of the most important tabs. So the common steps, think of this as all the steps that our algorithm deemed to be 100% necessary to complete the job plan. Planning, material, building scaffolding, this would be in every single past and future job plan for this functional location. The next tab up is unique steps. These are steps that our algorithm have deemed that Vanessa will need to go through and determine are these steps necessary for the job plan. So for send out to AWC, this step might not be needed. So it's up to Vanessa's discretion to say if this step will be added. Next up is the materials. These are all the materials that will be added to the job plan. And finally, at the bottom, there's a download button to download it to Excel. I will now pass it on to Ryan to explain how this will impact Vanessa's day-to-day.
Thank you, Taylor. So back to Vanessa. As you can see, based through the demo, Vanessa was easily able to use a simple search bar to look through the files instead of having to possibly go through File Explorer repeatedly. This saves her time, energy, and she's able to allocate her time to another job on the site. I will now be handing it back to Peter to explain the economic benefit that BASF could benefit from.
Thank you. So the initial goal that was set was to see a 2% efficiency boost for each job plan. Focusing back on the pressure safety valves, each job plan takes roughly just under 4.5 hours to complete. So 5 minutes would represent what we were looking for. With that 2% efficiency, that equates to over $13,000 saved per year. But at a full-scale production with 57 planners, 20,000 some odd job plans, and over 1,700 hours saved, we're looking at over $151,000 saved on an annual basis. This was our goal initially, but with our implementation, we are expecting it to be much more than this. I'm going to pass it over to David to explain what we could have done if we had a little more time and resources.
Thank you. So moving forward into the future, 3 ways that we could improve. Scaling. Obviously, there's more than just pressure safety valves going on in the maintenance department at BASF. Expanding this to other areas within the maintenance department so that they could also rapidly do their planning would be one easy way to scale this forward. 2, the AI assistant. In addition to finding documents quickly, frequently whenever these job planners are overtaxed, they get contractors that come in. They're unfamiliar with BASF procedures, they're unfamiliar with their file structures. We could put training materials in their procedures and other BASF specific information that would help them not just in planning, but in the maintenance department in general. This could be expanded further down the line. And 3, streamlining. We chose to use Qwen for our language model. Right now, BASF is heavily invested in the Microsoft environment. Going forward, we could try to incorporate this with Microsoft Copilot. If we had access to SAP's API, we could actually go in and develop an SAP output that would be pertinent and even more efficient moving forward. So for our final words, I want to call Valerio back up.
Thank you, David. I'd like to thank the team, Peter, Ryan, David, Taylor, and Nick. I'd also like to thank our sponsors, Kerr and Eric, for taking the time out of the day to come help us with this project and giving us an opportunity to work with them. And then I'd also like to thank Henry and James and Dean Colvin. Thank y'all.
And with that, well, let's give him one more round of applause, please. With that, I would like to invite the Our Lady of the Lake group back.